Good evening to Inchadi and my fellow friends. Today, I would like to present about gradient. This group member, Junaisa and Deepak. This is the title of we present calculate gradient of a tangent to a curve by applying the differentiation, complete the tangent and normal equation. This is the example of the gradient. First, we want to do x and y. Then we want to plot this is the curve line, and then this is the normal, and then this is the line tangent. This is the example of gradient. Second, normal to curve. This line is normal to the curve. This line, red line, is to tangent to the curve. This is the example of gradient. The equation of a normal to a curve. This is the tangent and this is a normal. The normal is a line at right tangent to the tangent. This figure is show how the tangent and normal drawing, how they are plotted. If we have a curve such as shown in figure 2, we can choose a point and draw in the tangent to the curve at the point. The normal is then at right angle to the curve, so it also at right angles perpendicular to the tangent. If now find the equation of the normal to a curve, there is one further piece of information that we need in order to do this. If two lines have gradient M1 and M2 respectively are at right angle to each other, then the product of their gradients M1 and M2 must equal -1. This is the main point in the gradient. M1 and M2 must equal to -1. Highlightation gradient. This is the key point for gradient. If two lines with gradient M1 and M2 are the right angles, then M1 and M2 equals to -1. This is the main key point for the gradient. Example, suppose we wish to find the equation of the tangent and the equation of the normal to the curve. How the example they are do. Y equals to S plus 1 over X. At the point where S equals to 2, first of all, we should calculate the Y coordinate at the point on the curve where S equals to 2. So Y equals to 2 plus 1 over 2 equals to 5 over 2. This is the example of the tangent and the equation of the normal to the curve.
Okay, my name is Dinesh Kumar Chandra. Today I will be continue our topic gradient. So next we want to find the gradient of the curve of the point where x equal to 2. So we need to find dx over dy. Nothing can we do. We can write y as y equal to x plus x -1. Then dy equal dy over dx is equal to 1 minus x negative power of -2 is equal to 1 minus 1 over x power of 2. Furthermore, when the x is equal to dy over dx equal to 1 minus 1 over 4 is equal to 3 over 4. Okay, this is the gradient of the tangent of the curve to the curve at the point 2, 2 and 5 over 2. We know that the standard equation to for a straight line is y minus y1 over x minus x1 is equal to m. So with the given value, we have y minus 5 over 2 and x minus 2 is equal to 3 over 4. So if we rearrange the table, y is equal to 5 over y minus 5 over 2 is equal to 3 over 4 x bracket x minus 2. Okay, so if you see in the chart, in the presentation you can see the way. So if you change the denominator from equal, it will go there as multiply. So 4 bracket y minus 5 over 2 is equal to 3 bracket x minus 2. So we can do our calculation here. So what if you times, you get 4y equal 10, 4y minus 10 is equal to 3x minus 6. So if we arrange that, 4y is equal to 3x plus 4. So the equation of the tangent to the curve at the point where x equal 2 is 4y equal 3x plus 4.
Thank you, Dinesh. As my part, I'm going to explain the same question. Now we need to find the equation of the normal to the curve. Let the gradient of the normal be M2. So suppose the gradient of the tangent is M1. Recall that the normal and the tangent are perpendicular and hence is M1, M2 is equal to -1. So we know M1 is equal to 3/4. So the 3/4 times M2 is equal to -1 and M2 is equal to -4. As we know the gradient of the normal and the point of the curve through which it is passed 2 and 5/2. As before this, y minus y1 over x minus x1 is equal to m. So when we use the numbers, y minus 5/2 is over x minus 2 is equal to -4/3. So when we rearranging the formula, 3y minus 5/2 is equal to -4x minus 2. So as per the formula, we have to expand the equation. So 3 minus y equal 3y minus 15/2 is equal to -4x plus 8. So we have to, after we expand the formula, we have to simplify the formula also. So it's going to be a 3y plus 4x is equal to 31/2. So when we solve the equation, the answer is 6y plus 8x is equal to 31. This is the equation of the normal curve that has given point. As per example, consider the curve xy is equal to 4. Suppose we wish to find the equation of the normal at the point x equal to 2. Further, suppose we wish to know where the normal made the curve again if it does. This is the question for the gradient. It is example. So the question is the gradient function of a curve which passes through A. It is 1 and 5. Is 3 square plus 2. So we have to find the equation of the curve. The solution is the formula for the solution dy per dx is equal to 3x square plus 2. So when we follow the formula y equals to 3x square plus 2 dx, we have to expand the formula. So it is going to be at 3x cubed over 3 plus 2x plus c. So when we flow the simplification, 3x cubed plus 2x plus c. So we have to factorize the equation and it is here x equal to 1 and y is equal to 5. So we have to just input the value of the x and y in the equation. So the equation is going to be a y minus x is going to be a y equal to x plus 2 plus c. So when we input the value of x and y is going to be 5 equal to 1 cube plus 2 plus c. So the c is 2. When the final equation is going to be y equal to x cube plus 2x plus 2. That's all from me. I will give from my another teammate. Thank you.
Okay. Question 2. Find the equation of the tangent and normal to the curve y equal x square plus 1 at a point where x equal 3. Okay. First, we need to find the gradient of the tangent, which is equal to, we need to differentiate x square plus 1. So I use symbol lab for this to find the answer. So I get 2x by using symbol lab. Okay. Now we get the differentiate for x square plus 1, which is 2x. We can proceed to replace x with 3. Because x is equal to 3, we will get 6. So the gradient of the tangent is equal to 6. For the gradient of the normal, we need to replace -1 over 6, because the formula is -1 over dy over dx. Okay, with the 2 point we can proceed to the next question, equation of the tangent at point 3 and 10. So the formula will be y minus y1 equal m bracket x minus x1. So y minus 10 equal to 6 bracket x minus 3. so we need to expand. So we will get x minus y minus 10 equals 6x minus 18. So then negative 4 will be good there, positive, so be plus. So y equal 6x minus 18 plus 10, we will get negative 8. So y equal 6x minus 8 will be the equation of the tangent. So next is equation for the normal, which the point 3 and 10 is, the formula will be y minus y1 equal negative 1 over m bracket x minus x1. So y minus replace y1 with 10 equal negative 1 over 6, which is the gradient of the normal, and x bracket x minus 3. So we will get 6y minus 60 equal negative x plus 3. So the final answer will be x plus 6y minus 63 equal to 0, which is the equation of the normal for question 2. So that's all from us. Thank you very much. To go to symbollab.com in any internet browser, then press d over dx, which is equal to the differentiation, and enter your question. In this case it will be x square plus 1. So then press the go button, you will get the answer. As you scroll down, you can see the step by step, and you can get answer, which is 2x.